Hello and welcome to Post Cloud. Hi, I'm Stephen Howell. I've been working in IT and the infrastructure side for quite some time, kind of moved through into solution design, spent a long time in the trenches working with virtual machines and networking and storage.
And hi, I'm Chris Krantz. My job seems to have gone full circle. I started as a web developer and graphic designer, moved into infrastructure, started putting things in data centers, screwing bits of tin into the racks and so on, and then got into cloud and nowadays back into programming once again.
We're going to be talking this week about containers.
In my last job, I spent the past 5 years selling kind of into container users and Kubernetes users. And I remember sitting down with some of the business development reps and kind of saying to them, look, you're targeting container users all day long. The trouble is, that's a real narrow view of who's using containers in the marketplace. The reality is that lots of people aren't and have no need to use them at all. Lots of people don't care about containers. They've got no need to care about containers. If you live and breathe this stuff every day, it might feel like everyone's doing containers. Reality is, it's still a pretty small number of people out there.
And especially if you're starting to work either on the very large corporation end or very small business side of IT, then you probably don't see a lot of containers. It's the section of IT in the middle where you're writing a lot of your own software and you're responsible for the software development and software release process. That then tends to be an area where containers come into the fore and begin to save you a lot of time and energy.
Everyone has the different use cases, everyone has the different needs. Containers aren't for everyone. Hopefully, through today's session, you'll still learn something though. So sit down, grab a drink, and let's chat containers. All right, so before we get too much into the technology of containers, what I want to do is kind of rewind it back a little bit and start framing the problem a little bit. So we're talking about application developments, how we're using applications. And if you go back, I don't know, 10, 20, 30 years, whatever, we used to build applications relatively statically. We might spend a year and a half, 2 or even 3 years developing and building an application, then releasing it. What people love to talk about as waterfall. As the industry moved on, people started speeding up that development, started looking at ways to improve that. How can I release once a year, twice a year, once a month? I think that's where people started using virtual machines. Stephen and I have got a fair bit of experience of people building applications and developing and deploying applications using virtual machines. It wasn't necessarily what virtual machines were designed for, but it was the tool that was available to them at the time to be able to accelerate things.
I spent a while doing infrastructure jobs, then kind of moved into virtual machine automation and saw that gradually shift into container orchestration in a very smooth way because the virtual machines that I was building were typically just a means of taking someone else's application and running it. And we would build those virtual machines using automation because we realized that it was a massive pain to do the same thing over and over again by hand. And so when containers came along, it was just this kind of, hooray, a tool to make everything a little bit easier because the virtual machines might take an hour, 2 hours.
So from an application perspective, we started going through this process of accelerating how we deliver these builds and how we'd improve the way we deliver our software. And then we started seeing some of the cloud giants, Netflix, Amazon, Google, all the rest of it, starting to do lots and lots of releases, really in a quite heavy cadence. And lots of other organizations started saying, well, we want to do that too. And this is where kind of containers really shrunk that gap. So they then started saying, okay, I don't want to have to wait 4 hours for my VM to build. I want to be able to do it quickly because I might make a mistake. And I don't want to wait 4 hours. It's bad enough that I've got a compiler that might take a 10, 20, 30 minutes to compile my application to find out I've got a mistake. I want to be able to build things quickly and do those integration testing.
It really matches how the application software is developed, as you say, Chris, that instead of just a single application, you had a single application and then it maybe had a web server and an application server. And then gradually the number of components increased. As the complexity of that software increased, the number of components and plugins and bits and pieces that you were combining increased, which caused this exponential increase in the number of iterations you have to make. Compare that to containers, where you not only have a lot of more automation around the updates, but you can decompose that virtual machine and tease apart the plugins and different components and put them in different containers. So each of those containers can be updated at a much more relaxed cadence. And you can track each of the containers much more easily because it's just got a single piece of software in.
You're kind of starting to describe microservices, and this is the journey you went through with those applications. You had these monolithic applications that used to take years to develop and deploy. As we got into these fast releases, we had to naturally you have to break up these services because there just isn't time to do all that.
So yeah, looking back where we came from with containers, if you were running a web server on like Debian Potato or something, you were probably using some sort of containerization technology. If you had your Apache web server back in the old days, then you were running it inside a chroot jail. And a chroot jail meant that the web server could not see the entire host operating system. It wasn't a virtual machine. It was a process that was limited to have its own file system where it could only see the files that it needed to run. Its mount groups were limited to just the files that it needed to mount to run a web server. So we had this concept of a chroot jail in Linux for a very long time. And if we look over at older technologies even, we can look at the kind of the Power IBM Power series. They had something called a logical partition or an LPAR, where the operating system could be subdivided and given amounts of resource for each of the processes. And the big revolution happened with Linux when a lot of kernel changes happened. Control groups started to appear. And if you've looked at containers, you might have seen C groups, right? A control group regulates access to certain types of resources. And the concept of a container is the instantiation, the application of all of these control groups to effectively bring together these technical functions and create a customer usable service. The customer usable service is the container. And so we have not just a mount namespace like we had for our chroot jail, which is the files you can see, the file systems that are mounted into that process. You've got a process namespace, which is the process IDs that are visible from your process. So maybe you can see process relating to a web server, but you couldn't see a process related to an email server that's also running on the same host. And you've got a network namespace. So each container is actually running its own network connection. And those can be bridged or go through NAT or some other means to get in and out of the host. But from the point of view of the container, it's got its own network stack, right? It is its own unique network endpoint. And when you put those together, you have the notion of a container, which in the Linux world is a group of resources that is going to have everything it needs to run its own processes and be self-sufficient. And at the same time, the rest of the environment outside of those namespaces are completely hidden from it, unless you choose to expose them.
I can definitely see why people would get confused between virtual machines and containers, because when you lay it out like that, they sound very, very similar. Virtual machines virtualize all that stuff. You have its own, you have your own process, you have your own storage, you have your own network. One of the things I think that really makes containers stand out is the kind of some of the concepts around immutability and idempotency. In some respect, they both come into play. They both have a should element to them. So immutability is the idea that things shouldn't change. When you've got a container, it should be immutable, as in it doesn't mutate, so it doesn't change from the original template. Now, there's lots of ways you can break that. In fact, built into containers is the ability to run a command when it runs the first time, which immediately breaks that concept. Sometimes, if you're not running a process, you can copy things into it at build time. So there's lots of ways you can break that immutability, and again, that's where it very much comes a should. The idempotency side of things is more of if I deploy this multiple times, it shouldn't have an impact on things. So I can use the same encapsulated application one time or 1,000 times, and I will get the same result. So it's that repeatability side of things I think is really important. In my experience, I think the immutability side is the one that a lot of people get wrong with containers, and a lot of people have blurred the lines between should and could. I'm not saying it's wrong. I'm saying that this is where we started from. This is what containers were designed to do. We've definitely moved a long way from what containers were designed to do to what containers do today.
We've got a number of different interpretations of containers. And I think we've been talking about the container concept that Docker Incorporated brought to the fore, which was later open sourced and standardized as the Open Container Initiative or OCI container format. We can also look at LXC containers, which are kind of another twist on it, where they say, well, maybe you can just put an entire startup system and operating system inside there, and the only thing you don't copy is the kernel. The two things those have in common is that you don't have your own kernel inside the container. And in fact, this is the crucial delineation between virtual machines and containers. The virtual machines are booting as if they are starting from physical hardware. They're looking at their BIOS or UEFI, they have a bootloader, and then they load a kernel. And then that kernel loads a file system and starts applications. Whereas containers skip that first bit and they borrow it from the host. They don't have a bootloader, they don't have their own kernel. They use the host's bootloader and kernel, and then they bring their own file system with their own applications.
I think that's really key to making them fast. Even the most optimized virtual machine could take 20 to 30 seconds to do a full boot, maybe a little bit quicker, but generally you're talking 20 to 30 seconds for a full boot. A container can take a second or two. It can be even less than that. Probably a terrible analogy for containers is samosas. Samosas, I love samosas. I went to India a couple of years ago, and my colleagues there welcomed me with a bag of samosas. That's how much I love them. But I think samosas are like containers. That's probably a terrible analogy, but bear with me. Samosa, you have potato, you got some vegetables, you got some spices, you got everything you need to make kind of a full meal. And then you package it up with some pastry and then you deep fry it. What could be better? And that's kind of my akin to having containers. Your containers, you take your application, you take the core ingredients you need for your application to run, you package it up and you deep fry it. Now, containers have some additional dependencies, much like good samosas have the additional dependency of some raita and some tamarind sauce and maybe some chickpea curry, so if you have samosa chat. Containers have that same thing. You have some dependencies on storage, on networking, security, on being able to users actually being able to get to it. That's probably a terrible analogy. So, what is Docker to containers? For a long time, I used to talk about, okay, we're going to deploy Docker, we're going to have Docker in our environment, when what I actually meant was containers. It's almost like a vacuum cleaner and a Hoover. You've got Docker and containers. What happened there?
Yeah, it is really just a trade term. It's owned by Docker Incorporated, and they were the ones that popularized a lot of the software around the concept of containers. They led the charge in the early days. Had Docker the company wanting to do more with Docker the technology and really own the market, and others really wanting an open source solution, the likes of Red Hat and Google with Kubernetes. And so this tension meant that Docker eventually decomposed the Docker container service into a bunch of different components and made it compatible with an open standard, the Open Container Initiative Standard, OCI for short. And so when people talk about Docker, they're referring to this old implementation of Docker because that's how containers started. But the reality is that most containers fired up around the world are not using Docker anymore.
So you've got these containers. They're by almost by design, they're designed to do a few things. They're designed to fail because they need to be able to fail, reboot, start, and just take over very quickly. The same things will also allow it to scale. So I can start with one, I can end up with 1,000, and I can scale, depending on your application, linearly across that. And they should be repeatable, which is part of all those things as well. Now, containers on themselves are relatively dumb. At the very, very basic level, it is just a process running. Now, if you're running a normal Linux server, you have something like systemd to actually start and manage those processes. So you have this mechanism of auto recovery. A container just being a container doesn't have that. And it certainly doesn't have any concept of how do I scale that out. So this is kind of where the concept of the orchestration comes in. You need something to manage the ability for those individual containers to recover from a failure, to scale up, to scale down, to be very, very repeatable. You could have exactly the same container used in 10 different environments doing slightly different things.
How do you turn that into a service? And the answer is that you need an orchestration layer above it that's going to handle what that immutable container can't do. It's going to handle things like persistence of data. It's going to handle passing configuration to the container. It's going to handle making sure that a container, once crashed, is started again, and to report back to the user on the health of the container. And when people talk about containers, they often end up referring not to the containers themselves, which are the building blocks, but to the orchestrations that take all these building blocks and provide house, a building, whatever you choose to make that analogy with, right? And when people talk about containers, they often think about the way that they're interfacing with those containers. What's the dashboard they use to control my containers, not necessarily the containers themselves. And so you're talking about those orchestrators, such as Kubernetes. So when we have a single container and we put something in a container to make it repeatable, we want to improve the reliability of that system. We put an application in a container so that we're able to repeatedly start it and get the same results. And so that we can monitor the health more easily, we can tell if it's failed, we can upgrade it more easily. What you're doing, in essence, is adding intelligence to that single component in the container. And so when you composite all these together, multiples of these in an orchestrator, what you've really done is take that single physical server you had back in the day with multiple applications on it, and each one of those little pieces of application exists as part of your container model. But now each one of those pieces is intelligent. It can heal itself. It can upgrade itself. It can maybe even scale itself. And so you've turned a single physical server with everything as just a red light, green light to a bunch of components where you understand the status of each, you understand the version and the potential for upgrade, potential for failure of each, and you've mapped out that application. You've effectively created this kind of ITIL fantasy land, but in a manageable way. Because ITIL never really worked for anyone, it was just a paper exercise. With containers and container orchestrators, you've taken that paper exercise and you've made it into something that actually works on a day-to-day basis.
As containers get moved into orchestration, we're still treating them as containers, right? That's our unit of operation. And then we talked earlier about things like the namespaces, the process, and the network namespace of those containers. All that stuff stays in place as you move into orchestration.
Yeah, that stays in place. And in fact, instead of having to deal with the complexities of those C groups and to call them out and manage them by hand, what the orchestrators do is provide you with a nice set of abstractions to say, this is a secure container, this is an insecure container, this is your production network, this is your backend network, this is your object storage, this is your block storage, and they enable you to wire your containers up and connect to these by providing some easily managed templated abstractions.
We've learned a lot about containers so far and even the orchestration side of things. And it feels like, because I work in this world, it feels like everyone's doing it, everyone's talking about it. Sometimes that can be a little bit daunting. It's kind of like maybe I'm being left behind because we're not doing containers. So I kind of want to talk about two primary use cases I see for why you might want to use containers. First one for me is comes from a story as when I was working for an end user. We were we had quite a big development team. We were a dot com, but we were always trying to improve what we were doing, try to go faster, trying to be more innovative, and all the rest of it, without compromising on quality. So the topic of containers naturally came up early. I think we were about 2013, 2014 there. So early days of containers and Docker. And what the development team wanted to do is have something that was highly repeatable, but more importantly, they could provision in different places. This company were they had a UK base. They were starting to move into the cloud, but they also had an Asian base. So they needed to be able to deploy locally within an Asian cloud in order to get local latency and so on and so forth. So containers were the obvious choice for them. They wanted to be able to package things up, have this repeatable experience. So when they were developing on their laptop and deploying into the data center or deploying into the cloud, everything was going to be the same. And I feel like that's probably the most common use case for me is you've got in-house developers. You are an in-house developer yourself. You're building applications and you're looking at doing things in an optimal way. We talked earlier about that waterfall approach, and I think what a lot of people who don't come from development backgrounds may not appreciate is just how many different environments you could have. When you're talking about this microservices world, every team is working on a different component within that application. But in order to release their application, they have to be able to test it. You have to be able to do interoperability testing across all the different components. And everyone has to have their own environment to do that because my releases shouldn't affect your releases and your releases shouldn't affect mine if I'm doing a bad release in terms of the testing those releases. So you end up with half a dozen or more different environments, sometimes they're per development team as well. One release a month, one release every 2 weeks could actually mean 10 releases every 2 weeks because you've got all these test releases through that. You've got these different development releases as you're doing it, as you're checking to see, is my code actually going to work?
Outside the development world, as an infrastructure guy, I know you're testing on your laptops, and then in infrastructure, you would have, at the very least, a quality assurance, a development environment, and a prod environment. And you typically see them transition from development through to quality assurance and then to prod. And whether it's QA or test, whatever you want to call it, the staging environment. And a very large people, they probably have a replica of their production environment, just prod one, prod two, so you can be absolutely sure that if you mess something up, you don't take down absolutely everything.
The second use case I've got around building containers is when you're an application company or delivery company or even a services company, perhaps, you want to be able to ship your application in a way that is repeatable. I remember working with vendors who have to build software that can be deployed in any number of software configurations. And to do that in the back in the good old days, you used to build these environments. You would build physical servers of all the different flavors and varieties you needed to test against and test to see if your software works. You can't it's not that you can't do that nowadays. Of course you can, but it's a very expensive thing to do and it's very time consuming. So what we do instead is we package it up. You package up all those dependencies and everything, and containerization is a great way of doing things.
And another word on those dependencies, I think if your application needs a specific version of a library, do you even know that that version is going to be equivalent from, say, Debian through to Red Hat? You hope it does, but it's entirely possible that that library is built with a different argument that enables or disables features across distributions. So you never truly know. So your choice is either to run a bevy of test machines for every distribution under the sun and maybe the last three versions of them. Or you can simply supply the version of the library that you know works and hide it inside a container. So your application sees that you're running your operating system of choice inside that container, and you've got the libraries that you want inside that container. So I think we've talked about the motivation for a lot of these technologies in the past, Chris, and it comes down to the same solid reasons. Containers are no different here. Containers are there so you can save time and have less issue installing and upgrading your environment. They're there to provide fewer help desk tickets by providing fewer errors when libraries may match or not match properly on the underlying systems. And they're to have fewer bugs in production by allowing you to more easily test the software in a variety of different pre-production QA test environments. And they're also to smooth over the cracks with different operating systems to smooth out those behaviors. They also facilitate the adoption of more advanced application development patterns, such as microservices, and containers are often seen as going hand in hand with microservices. So if you decided on a microservices architecture, containers are going to be part of your toolkit, and they'll help you get the job done. On top of that, we also have the ease of shipping applications. So if you're an application vendor and you want to ship artifacts to your customers, in the past you would have shipped a virtual machine or an application install package. Well, these days you can ship a container and it's going to be small and lightweight, and you can make use of existing distribution architectures like Key.io or Docker Hub, which will allow you to take your application and have it hosted on a global content delivery network without you having to go to the trouble of making sure your customers can access it.
We're moving from those virtual physical machines, even the cloud instances, which we used to think were really, really quick way of doing things. You've probably heard this before, moving from pets to cattle, where you've got these container instances that just die really quickly. They were replaceable. You've got lots of them. You've got a whole fleet of them. We're moving really beyond the cattle, moving more into locusts these days, where you just got giant swarms of them. You can have a relatively simple environment. If you think about the different environments we talked about earlier, you can have a relatively simple application that suddenly needs hundreds or even thousands of individual containers. There was a couple of years ago, there was a Kubernetes recommendation document from one of the Department of Defenses in America. They were saying in order to deploy a robust kind of container environment, you needed different things like log management, security, secret management, all different things. Each one we deployed as a sidecar. A sidecar means an additional container. So every single container you deploy would have 5 to 6 other containers. and then multiply that out by the number of environments, multiply that out by the number of availability zones or the rest of it, and you quickly get into this realm of having hundreds or thousands of containers.
In many ways, this is also characterized as a shift from enterprise as the dominant computing model to cloud as the dominant computing model, where we have a lot of hand cranked artifacts on the enterprise side versus hyperscalers showing us that all this can be done via orchestration and automation, and infrastructure becomes codified instead of manual.
It's taking that mindset shift from that enterprise way of doing things where you cared about your individual deployments and applications, and things became a little bit more handcraft, even down to little things which might seem obvious. You got a problem in production, you log into that box to have a look what's going on. That just doesn't happen in containers. You have this cloud native mindset instead, where something's going on with one of your containers in production. Kill it, reboot it. I'm going to go and consult my log manager to see what was going on. I don't need to be directly on that box anymore. Some people are struggling, and sometimes you get this pushback or this hesitance to deploy it. Back when I used to go into data centers, it's a huge security thing to go through to get access to a physical data center, to be able to put in a USB key, to be able to install a new server. It's very, very tightly governed. Whereas nowadays, with containers and container orchestration and cloud, we give the keys to the data center to many people across the organization, and they can deploy straight into production, publish something immediately to the internet and to their users. And very few people are involved in that. And there's very much a different mindset shift that's required as we're going to embrace that. That's not to say it's not carefully governed and security isn't in play there, but it's applied in a very different way. I guess one of the things we talked about earlier, containers is not for everyone. Containers, you're not always going to have a use case for them. I feel like everyone is going to end up running containers in some shape or form, but you're probably not going to know you're running containers. And I think that'll happen for many people. You're going to be running containers whether you like it or not. And if you don't like it, that's fine. You don't have to worry about it. Containers are more relevant to the people that are actually going to interface with the containers. And I think that's the thing that's one of the takeaways is to have a look at that. Do you actually need containers?
As with all these technologies, decide how they can help you. And if there's something that looks like it's going to make your life easier, take the time to read about it. A little bit of reading and some experience now can mean countless saved hours, saved days down the road. A lot of businesses struggling with IT, they'll say that they can't do this because of this network issue or this storage issue, this operating system issue, or this hardware issue. And a lot of problems are not down to necessarily the technology that you're using, but the way that businesses are communicating as well. And so I've seen people say, oh, we can't adopt containers because it doesn't fit our network layer. Or we can't work with containers because our storage product doesn't support it. And I think a lot of these problems, not necessarily problems of the technology tool set, but they're problems of the business topology and the business silos. And so it's great if you're in a position where your business can adopt these technologies to make your life easier, but encourage people to talk, because there's a lot of business problems that really are just communication problems.
And these are not new objections. We've had all those same objections when it came to, moving to the cloud. Oh, we can't do that here. Networking, security, yada, yada, yada. When we first started doing virtualization, we can't do that here. We've got these different isolated silos. We couldn't possibly do virtualization and knock those down. Before that, it was moving to x86 away from mainframes. We've always had these excuses, and they haven't stood for long. Thank you very much for sticking around to us and listening to our episode today. I was talking about containers. Like I said before, it's a topic that's close to my heart. I spent a lot of time working with this, and I, Stephen, say for your experience. Thank you very much. As always, if you're watching us on YouTube, hit those like and subscribes. If you're watching us or listening to us on a podcast anywhere, don't forget to subscribe. Please, we would love it if you'd share this with people who you think would be interested as well.
Thank you very much, everyone. You can also find us on iTunes and Spotify and all those other podcast apps. And next time we're going to be pursuing this one a little bit further, diving into those container orchestrators and talking about Kubernetes, or is it Kubernetes, or is it Kubernetes? Anyway, much more on this next time. Bye for now.
Thanks a lot, folks. Take care.